Hello everyone, today I'm pleased to share our work accepted by ICC in 2023 partner level up the polar representation for LiDAR 3D object detection. Unlike regular camera images, LiDAR point cloud has its own unstructured and sparse nature, thus requiring an effective representation for 3D object detection algorithms in real world. Compared with contention-based representation, polar representation has its potential superiority in several applications, robust performance under dynamic resolutions and streaming detection. Despite its promising characteristic, polar-based 3D detector inevitably suffers from severe feature distortions. To address these above issues, we present a novel polar representation detector partner to learn effective representation and shows overwhelming advantages in streaming-based detection and different resolutions. To tackle the problem of feature distortion, we designed two targeted modules, the Global Representation Realignment and the Geometry-Aware Adaptive module. We first introduced the Global Representation Realignment, a simple yet effective module that applies attention to those essential features for global alignment. The idea behind this design is based on the observation that the spatial resolution of polar grids varies depending on the range and azimuth. With such differences, two identical objects in different locations could occupy a different number of pixels. However, one significant characteristic of CNN is the translation invariance, which contradicts with the above polar spatial properties. It results in the feature distortion problem found in existing polar detectors and worsens the performance of the CNN-based feature extractor, and thus we proposed our translation awareness operator to realign polar features. To this end, the global representation realignment is designed with two kinds of attention submodules. The first is the condensed attention for column feature condensing. The operation is based on the prefect that in polar BV maps, the pixels along the radial directions encode points from a small scanning angle. The information in each column is limited due to the collision between objects and is distributed in a concentrated manner on the surface of objects or stars. Therefore, the condensed features generally indicate where the 3D object is likely to appear in the 3D scene and could be regarded as representative querying pixels of the column. Introducing these features avoids noise and the computational overhead introduced by the background area and maintains the diversity of object features in the range aspects. Secondly, observing that a distant feature encodes a much larger region than nearby features, thus it is necessary to introduce an appropriate paired receptor field in azimuth, which helps distant features access enough nearby features for realignment. After angular attention, we apply a reverse condensed attention to broadcast the realigned representative features of each column of the BV map. Our model employs two stacked modules for information interaction, where the second angular attention uses a shifted window partition. Similarly, the Geometry-Aware Adaptive module introduces translation awareness geometric clues to the feature aggregation process, and it produces the final detection results. We extensively validated the effectiveness of our designs on the Waymo and one-state sites. Particularly, our partner achieves compatible results over the state-of-the-art method and demonstrates overwhelming advantage in streaming and different resolution scenarios. And here is a visualization demo of our partner. To sum up, we revisit the problem of feature distortion in the polar representation, which restricts the polar-based 3D detectors severely. We elevate the dilemma of feature distortion with global representation realignment and facilitates the regression by introducing instance-level geometric information into the detection head. Results demonstrate the proposed method outperforms the previous polar-based works with a large margin and achieves competitive results over the state-of-the-art method.